All right, today's lesson is prime factorizations, is notes and examples. This should be a review of what you have learned last year, but I'm going to go through this again. So prime numbers, if if it's in your note, you need a copy. It's not in your notes, are the numbers that have only two factors that are one and the number itself. So the only number that goes into these numbers, like 2, 3, 5, 7, 11, 13, the only number that divides into it is 1. No other number divides evenly into that. Whereas composite numbers is a number greater than 1 that has more than two factors. So 4, could be 1 times 4. It could also be 2 times 2. So that has multiple factors. Same thing with 8. 1 times 8, or 2 times 4, or 2 times 2 times 2. So again, these are examples of composite. And then, of course, our definition, prime factorization, is breaking down the number into a set of prime numbers which multiply together to result in the original number. Prime numbers, factoring, that means the factors are multiplying the parts of a multiplication number. And so we can for the examples, we have 8, which is not 8, 12. 2 times 2 times 3 is the prime factorization of 12. And we can also rewrite those as an exponent statement. 2 to the power of 2 times 3, or 2 squared times 3, is also going to equal 12. If you need to pause the video, that's fine. Pause and so you can get your notes. That's okay. So now here we have an example. If we're going to factor the number 42, we are going to use a lot of our divisibility rules that you have learned. For example, if the number ends in an even number, then that number is divisible by 2. If we add the total sum of the digits, so 4 plus 2 is 6. If that number is divisible by 3, then that will go into it. If the number is divisible by 2 and 3, 6 can go into that number. So those are some of our divisibility rules, but we're going to start with our basic one that's the easiest. It's an even number. 2 goes into it evenly. So 2 times 21. Now, if one of our factors at the branch is a prime number, we're going to go ahead and circle it so we know that we're done with that branch and it's a prime number. So now we have 21, and we know from our multiplication tables that is 3 times 7. 3 and 7 are both prime numbers. So now that we have all prime numbers at the bottom of our branches, we're going to do our prime factorization is 2 times 3 times 7. And if one factor is a prime number, then circle it or identify it somehow. That's how we know. I'm just saying circle it is a good method to help us see those prime numbers. All right. Here's another example. Of course, 48 we know is even. So we're going to start with our 2. Goes in 24 times. We know that 2 times 12 is 24. Of course, our 2's are prime. We have 12, which is 2 times 6. You can also do 3 times 4. But for this particular example, I'm just using the 2's to stress we can always do the even numbers the easiest. And then we have 6, which is 2 times 3. And all of these are our primes. So 2 times 2 times 2 times 2 times 3 gives us our number of 48. Or we can also use our exponents, 2 to the 4th power times 3. We don't always have to use 2 when it's an even number. If we know that there's something that's larger that goes into it, that will make less brackets that we have to do. For example, for 36, we know 36 is a perfect square. So 6 times 6 is 36. We could have used 9 times 4 also. We could have used 2 times 18. All of those are options. They all come to the same answer. We're going to use 6 times 6 for this example. 6 times 6 breaks down into 2 times 3, and those are our prime numbers. And then we have 2 times 3 again. So our prime factorization of 36 is 2 times 2 times 3 times 3. We can also write that as 2 to the second power times 3 to the second power, or 2 squared times 3 squared. We'll go on to our next example. Here we have 96. The bigger the numbers, the more ways that they can be done. We know it's even. We could have done a 2. I chose to do a 4 just to show you don't always have to do the 2. So 2, if we use our 4, 4 goes into 96 24 times. 4, we're going to use 2 times 2. Those are both our prime numbers. Here we have 24. If we break that into divide by 3, because 2 plus 4 is 6. 6 is divided by 3. So the sum of the digits is divisible by 3. And that's 3 times 8. And of course, we can break that down further into 2 times 4, and then 2 times 2. So our factorization, our prime factorization is, oh, I made a mistake. Look at that. This is actually 2 times 2 times 2 times 2 times 2 times 3, or 2 to the 5th power times 3. So that's the correct factoring. And our last one is an example that you can do. There are multiple ways. You can start with 2. You can start with a 4. Either way will get you the same answer. So I'm just going to write this in for you. Now, if we do a 4, that would be a 19. 4 times 19 is 76. And then we come down here and we have 2 times 2. So our prime factorization is going to end up being 2 times 2 times 19, or 2 squared times 19. So that's one method. Again, I said we could also use our even number is divisible by 2. So I'm going to go ahead and erase these. Again, if you needed to pause the video, you can. I'll do this one in red. So if we use 2, 2 times 38 gives us, and 38 is 2 times 19. And as you can see, we end up with 2 times 2 times 19. Again, the same answer. So those are our primes. If you have any questions, feel free to email me or ask me in class. Until then, I will see you in class or online.